Hey, welcome back. My name is Rahul, and in the next few videos, we're going to develop a full-featured Android app using the Google Maps API. One of the powerful things about mobile phones is that they're mobile. As a result, being able to integrate location and map data into whatever you're building can unlock a lot of really cool functionality. For example, the app that we're going to build. This app will allow you to keep track of important places in your life. In the process of building this app, not only will we learn how to interact with the Google Maps API, we'll also learn how to pass data back and forth between different screens in your app. In addition, we'll also learn how to save data to a file. Keep watching so we can build this together. Before we start coding, there are three things I want to talk about. One, I want to provide some background on the app and give you a demo. Second, I want to talk about the main concepts we will and won't cover. And finally, I want to talk about how we're going to build the app and breaking it down into different milestones. The first, some background. The app that we're going to make is a clone of a really popular app made by Google called Google My Maps. The idea of this app is really similar in that you can keep track of places that matter to you. You can make custom maps to remember your favorite places, explore new cities, or plan great vacations. This app, of course, has more functionality because it has millions of downloads and a whole team working on this app. For example, you can do things like search and navigate to places that you can't do in our app. But if you're interested, drop a comment and we can keep adding more functionality from Google My Maps into the app that we're building. In terms of what you should know before beginning this project, I'm building the app in Kotlin, so having some knowledge of programming will be valuable. Don't worry too much about the Android concepts because I'll introduce them to you as we encounter them in the app. If you are totally new to Android though, I'd recommend that you start with this playlist, which I published a few weeks ago, around building a tip calculator in Android. The tip calculator is a really great first app because it's a lot simpler compared to what we're building here. So I'll leave a link to this in the description if you're interested. Now I'll do a quick demo of the app so you can see what we're going to build. The main screen of the app shows a list of all the map titles. So here I already have 5 maps. I'm going to Singapore on vacation in a few weeks, and so I made one map which is about all the places I want to go in Singapore. So if I tap on that map, you can see we navigate to a map view which shows all the markers associated with this map called Singapore Travel Itinerary. I can tap on one of the markers to learn more about what I had written about it. So here's Sentosa Island, and then I can tap on another one to learn more about that. And the cool thing here is that we have all the functionality of a normal map. So I can double tap to zoom, I can zoom out, and I can pan, which just means I can move the map around. Of course, the map wouldn't be that interesting if all you could do is view an existing set of maps. We'd like for the user to be able to create a new map. And so you can tap on this plus button in the bottom of the screen and provide a new map title. So I'll call this new map California Regions. And you'll notice at the bottom there's a dialog here which says long press to add a marker. So if I tap on that, this gives us a hint of how we can add more data into this map by long pressing. So if I long press, I have a dialog that shows up which prompts me to enter in a title and description. The one really important thing is error handling. Whenever you're collecting data from a user, you need to make sure that that data is sanitized and it's well formatted. So if I try and create a marker right now, for example, you'll see that we have error handling which says the title and description must be non-empty. I have to input some valid data here. So I can say NorCal, I can say my fave, and then I can zoom out a bit. Oops. And I'll drop one more pin in SoCal. So the 2 regions of California. And this is not my fave. Now, at the top right, there's an option here to save it. And as soon as I save it, you can see that we've added one more element into the recycler view, into the list, which is the new map, California Regions. And if I tap on that, you can see both of the markers that I had added. Next, I'll talk about the main concepts we will and won't cover while building the app. The first, of course, we'll be talking about how to integrate map and location data into your application because the main point of what we're building is rendering a map and showing important places on it. Second, we'll talk about how to navigate between screens in your app with data. This is important because pretty much all apps will have multiple screens and you'll need to be able to communicate between them. And we'll use Android's intent system to do that. And third, we'll talk about how to persist data. So even if the user closes the app, they expect that all the created maps that they have inputted into the app will still be there when they come back to it. And the way we'll do this is by saving all the map data into a file. There's also a few concepts which we're not covering, which is good because it'll make our app simpler and we can really focus on the core concepts. So first, we're not going to be doing anything with networking or the internet. As soon as you introduce talking to an API or a server, your app becomes a lot more complicated. And second, we're not going to be persisting data with a database. Generally, when you have structured data, which we do have in this app, it's recommended that you put it into a database like SQLite. However, there is some additional complexity that you have to deal with when you work with something like Room or other databases, so we're not going to be doing that in this walkthrough. Finally, I want to talk about the steps we're going to take in order to build our application. The first, we're not going to worry at all about actually rendering a map. Instead, we'll just render a list of all the map titles in the main activity. Next, once you tap on one of the map titles, we want to navigate to a different screen where we show the map along with the associated data, which are the different markers you can see. After that, we'll spend a few videos doing the creation flow. So that's the flow that you enter into when you tap on the plus button on the bottom right of the main activity. We'll also spend one video here talking about how do you save all the map data into a file, so when the user comes back into the application, we can read all that data from that file that's persisted. And finally, we'll have one video dedicated to polish and animations to make our app feel a lot better. So you can tell looking behind me, I have a bunch of maps that are always in my room. So I had a lot of fun building out this project. I hope you do too. As you're going through it, if you get stuck anywhere, if you have any questions, let me know. I'm here to help as much as I can. Don't forget to like and subscribe, and I will see you in the next video. The goal for this video is to achieve milestone 1 for building our app, which is to display the list of titles of each user map. We're going to display this in a recycler view, and I have an extensive video about the reason to use a recycler view and what the benefits are. So I'm not going to go into too much detail here, but if you're interested, I'll leave a link to that in the description. In order to make this go faster, I'm going to provide you with some dummy data so you can have something similar to what you're seeing on the screen here. Let's start with opening up Android Studio and create a new Android Studio project. Start with empty activity, and let's call this My Maps as a name. Language is Kotlin, and minimum API level is fine, and then let's tap on Finish. So initially, Android Studio is going to take a bit of time to build your project. The very first thing I like to do whenever I create a new project is just to run the app and make sure that we see Hello World properly, because that'll give us a guarantee that we're starting at a known good place, and anything we build on top of that, we know how to get back to something which is working. I'm going to tap on this green triangle in order to run the app. We are able to see Hello World properly, which is what we get from the empty activity starter project. The next thing I'll do is, instead of showing Hello World, in the underlying view for the main activity, which is activity main.xml, we don't want to show Hello World, we want to just show a recycler view, and the recycler view will hold all of the titles of the maps. So I'm going to expand this to give ourselves a bit more room, get rid of Hello World, and then we're going to drag out a recycler view. So recycler view needs a dependency, so then Android Studio can help add that dependency into your build.gradle file. And I've noticed sometimes that when you initially drag out the recycler view onto the view, the attributes tab doesn't open up. And one way to remedy that I found is if you just run the app, then Android Studio picks up the change and then it's able to show you this attributes tab. So once you're able to see that, then you can set the width and height to be match parent, because we want to fill up the whole view with the recycler view. And also will give us an ID of RV map. So RV means recycler view. So now that we have an ID, we can reference this recycler view inside of main activity. So there are two things we want to set on the recycler view. One is the layout manager and the other is the adapter. I'll leave links to the prior videos about recycler view if you want a deeper dive, but as a quick overview, layout manager is responsible for telling the recycler view how to lay out the views on the screen. So either in a grid, staggered grid, or a vertical linear layout manager or a horizontal linear layout manager. And the adapter is responsible for taking the data, so in our case, the user maps, and binding it to a particular view in the recycler view. In order to make the adapter part work, one thing that's obviously very important is the data. And in general, data is actually really important for any app you build, because typically the way you structure your app and the way navigation will work in your app will all really depend on the data. So that's something that we're going to define right now. So I'm going to change the view of the project to be the Android view, just because I'm more familiar with that. Let's define a new package called models. And the obvious model that we have in our app is a user map model. And the user map represents a map that the user has created. So this is going to be a data class in Kotlin. And the idea here is that we want to put the attributes of the user map inside of the data class. One thing that every user map must have is a title. So we'll say val title, and this is going to be of type string. And then the second thing a user map must have is a list of markers, and each marker really represents a place. We want another attribute called places, and this is going to represent a list of place. And place is going to be another model that we define inside of our models package. Place, if you remember from our demo, a place is a marker which is at a particular location on the map. When you tap on that, we show a title and a description for what is located there. So we'll have a title, which will be of type string, and a description, also of type string. And then we want to specify the location. The location will be represented as a latitude and longitude, each of which will be a double. Great, so now that we've defined place, we can go back to user map and we should be able to resolve the error. Now that we have the models defined, it will help us to set up our adapter. So the layout manager is actually pretty simple. Let's do that first. So all we want to do is set a layout manager on the recycler view. So we'll say we're going to use a linear layout manager, and by default you pass in a context, which is the activity, and it'll be a vertical layout manager by default, which is what we want. Next, we want to set the adapter. We're going to define a new class called maps adapter, and it will take in two parameters, one which is a context, this, and a second which is our data, which will be a list of user map. So for now, I'm just going to pass an empty list of user map, and eventually we're going to actually put in some actual data there. We can have Android Studio help us to create this maps adapter class. So I want it to be in the same package as main activity, so that's fine. The Android Studio tried to be helpful and give us meaningful names for each of the constructor parameters. It didn't do that great a job, so let's help it out. So the first parameter will be a context, which will be of type context, and the second parameter will be a list of user maps, which we're going to call user maps. This inherits from recycler view adapter, and that is parameterized by a view holder. So I'm going to define an inner class view holder, which is inheriting from the recycler view holder. And this needs to match the constructor of the parent class, which takes an item view. So now I can reference this view holder here. Now we're able to implement the abstract methods of the adapter class. There are three methods. We're going to implement all of them. And my personal preference is I like to have the view holder at the very bottom of the class. The easiest method to implement is get item count, because literally all we need to do is get the size of the user maps. That's how many items we have in our recycler view or in our data set. Next is on create view holder. The job here is to inflate the view and wrap that inside of a view holder. So we'll say layout inflator.from, and we need to pass in a context here, and we need to inflate the layout. So instead of defining our own custom view, we're going to leverage Android's built-in layouts. So there's one of them which is called simple list item 1. And so we're going to inflate that view, and I'll show you what that looks like in a minute, but we're going to wrap the inflated view inside of a view holder. On bind view holder, the job is to grab the data, which is at this position, and then attach it or bind it into the view, which is located inside of the view holder. So getting the user map at that position is easy because we just index into our user maps. And then binding it is also pretty easy. This is where we need to look inside what is this layout. So if I go into the definition of that, you can see that it's really simple. It's a text view and it has an ID of text1. And there's some other things like padding and gravity that we don't care about right now. Basically, all this is for our purposes is a text view, and we can use that to go a little bit faster at this stage. So going back into map adapter, we know that the ID is text1. So now we can grab that text view. So we'll say val text view title is equal to holder dot item view and grab that view. And in order to reference that ID, we need to say android.r.id because it's coming from the Android SDK. And then we want to set the text attribute of that text view to be the title of the user map. Okay, let's run the app, and we don't expect anything really to change because we're not actually providing any data to the adapter, but we should see just an empty screen. And there you see that we do. What we'd like is to have some data to work with. It's not that hard to actually generate your own sample data, but in order to speed up the process, you can feel free to use the data that I provide you. So here's a gist from GitHub. So tap on raw, and then you should be able to copy and paste this directly into your main activity file. So let me quickly walk you through this. So there's a method here called generate sample data, which returns a list of user map. And all we're doing here is we're using Kotlin to make this really concise. We have a list of, and we're providing a bunch of different user maps. And each user map consists of the attributes that we've already defined in our data class. So there's a title and a list of places. So for example, here we have a title of the map as Memories from University, and we're containing a list of 3 places, Branner Hall, Gates Computer Science Building, and Pinkberry, with a description and a latitude, longitude. So now we should be able to call this method. I'll say user maps. And now this can be the data that we pass into our adapter. So now that we have some sample data, when I run the app again, we should now see the titles. And there you can see we do. And nothing else happens if I tap on it, which makes sense. That will be the goal for the next video. If you like this, don't forget to like and subscribe, and I'll see you in the next video. Our goal in this video is to pick up where we left off, which is showing a list of map titles in a recycler view. When a user taps on one of the titles in the recycler view, we'd like to navigate to a new screen or a new activity, which will render a map with all of the places in that map shown as a marker. This is where we're going to be talking to the Google Maps API. In order to be able to navigate to a new map activity, the very first step is we need to understand when did an item in the recycler view actually get clicked. The way you would typically do this is by setting a click listener on the item view. And so you can imagine doing something like this. So we say holder.itemView.set on click listener, and then you take some action. So let's actually just try that. So I'm going to define a tag. And the tag will be the name of the class. That's the convention. So now we can say tapped on position. So if I open up Logcat and we can see maps adapter, we do see the taps on various positions. What we'd like is main activity to get notified of a tap, and then main activity should be the place where we do the navigation to another screen. So what we'd like is when user taps on an item, we want to navigate to a new activity. So the question then becomes, we're able to listen for clicks right here. We want to notify the main activity when this happens. The way we can make this work is by defining an interface in the map adapter and passing an instance, an implementation of that interface in the maps adapter constructor. And so we'll say interface on click listener. And this is going to have one function called on item click. And it'll take in a position. And now we're going to add this as a parameter onto the constructor. So going back into main activity, we have an error here that we haven't passed in an instance of that interface. So let's do that. And we need to define an implementation for that method. And let's put a log statement here as well. So we're passing in an implementation of an interface, but we're not doing anything with that interface, right? This is unused. So the idea, the way this is all going to tie together is when the item view is clicked on, we want to fire the method on that interface. So we'll say on click listener dot on item click, and we'll pass in the position here. So now every time a user taps on one of the items in the recycler view, we'll call this on item click method, which is part of the interface, and that will then alert this code to be fired, and we'll get the log statement. So let's try it. So now we expect to see 2 log statements every time we tap on an item. One is from maps adapter, and then one is from main activity. Great, so that works. Once the user taps on an item, we would like to navigate to a new activity. That'll happen inside of the click listener. The way Android does navigation to different screens is through something called an intent system. So if you Google for code path intents, you should be able to come to this guide to talk a bit more about what is an intent and why we should use it. So intents are fundamental to how Android thinks about navigation between different apps and within your app. An intent is a message that can be thought of as a request given to either an activity within your app, an external app, or a built-in service. So an intent is a way for your activity to communicate with the outside Android world. So you can use intents to take the user to another screen within your app, which is what we're going to do, take the user to a particular URL within a web browser, and there's a few other examples given here. There are 2 types of intents. One is explicit and the other is implicit. We're going to be using explicit intents because those are used to launch other activities within your app. The new screen that we create, which is for rendering a map, that's going to live within our application. That's why we're going to be using explicit intents. Implicit intents are used to ask the Android system to open up any activity that can handle the intent that's described. So for example, you could imagine, I want to make a phone call. I want any phone app to handle that request. Another example could be, I want to get a picture. So it doesn't matter where I got the picture from, but I want to fire off an implicit intent to the Android system, and the Android system will return to me any application that can handle that. The way to launch an explicit intent, which is what we're doing, is through something described here. So I'm going to go into the Kotlin tab. We're going to create a new intent object. We pass in a context, which is where we're coming from, and a second parameter of the intent object, which is the class we're navigating to. So we're going to do something very similar in our main activity. So we need to have a class which we navigate to. The way we'll do that is open up project and open up the directory where main activity is located. We're going to create a new activity right here. That's the activity which we're going to navigate to. So go to new and go down to activity and go to gallery, because we're going to actually create a new type of activity that we haven't created before called Google Maps activity. So tap on next and call this display map activity, and then tap on finish. So Android Studio is doing a couple different things for us here, and let me talk you through what exactly it's doing. First off, in the manifest file, every activity that's in your app has to be registered in the manifest. So the first thing that Android Studio did for us is it added this line. So now we have display map activity. The second thing it did is it created a new Kotlin class called display map activity, which is what we're going to fill out. It also created a corresponding layout file called activity display map. All it has is a fragment, and that fragment is a support map fragment, which is what is actually rendering the map. And then finally, there's Google Maps API.xml. So this is where we need to specify a Google Maps API key. So in order to render a Google Map in your Android application, Google needs to make sure that you have the proper permissions to do so. And they also want to make sure that no one is abusing their service, which is the Google Maps service. And so every developer needs to have a Google Maps API key, which you specify here, and that's how Google can make sure that no single developer is taking up too many resources. So by default, there's like a dummy key here, which we'll need to replace in order to get this working. But luckily, this process is really simple. All you need to do is open this link in the browser, and this link has embedded as part of the parameters of the URL exactly the kind of key that we want. So we're going to be fetching this map from an Android app, which is why we have key type client-side Android. And it also has a couple other parameters. For example, here's the package name of our app. And there's also a SHA-1 certificate fingerprint. These are different attributes that Google requires in order to verify the authenticity of whoever is making the request. So I'm just going to open up this URL in the browser. On this page, we need to register our application for the Maps SDK for Android in the Google API console. So either we can take an existing project that we have already, or we can create a new project. I already have an existing project, and I'm going to add the Maps SDK to that one. So I'll say continue, and now it tells us that the API is enabled. So now we can tap on Create API Key, and now we can copy this API key that's generated for us. So copy that and then close it. If you want it to be more secure, you can restrict the key so that only certain apps and package names can access this key, but that's all we need. So I'm going to copy that to the clipboard, go back into Android Studio, and then paste it in to this file, Google Maps API. Now that we have the display map activity set up, we need to navigate here. So let's go back to main activity, and we'll use the content from that code path guide about creating flows with intents. So I'm going to create a new intent object. And it takes in two parameters, one which is the context, so that's the main activity. And then the second parameter is the class that we're going to. So that will be the display map activity.java, that class. And then to actually do the navigation, you have to call start activity with the intent. So if we try this, if we tap on a item in the recycler view, we should navigate to the new activity. You see that we do navigate to the new activity, but the maps are not rendering. Sometimes what happens is, as soon as you create a new API key, it'll take some time for it to actually register and become valid. So one thing I found which will help the process is just uninstall the app from the emulator and then reinstall it. So I'm going to go ahead and uninstall it. And then let's reinstall the app from Android Studio one more time. And now you can see we do see the maps render properly. So let's take a look at the starter code in the new map activity to understand why we're seeing this view. So if you go into display map activity, you can see that we have display map activity, and it implements this interface on map ready callback, which is why we have this override on the on map ready function. Basically, we have the corresponding layout file which contains the fragment, which is a support map fragment. We're getting the support map fragment, and we're calling get map async, and we're passing in the on map ready callback. So basically, this support map fragment is going to do all the magic of rendering the Google Maps API. And when we want to get notified that the maps are ready to be rendered, then it will notify us through this method. It's worth noting at this point that in order for your Android phone to be using the Google Maps API, it needs to have Google Play Services installed. So as you can see from the comment, if Google Play Services is not installed on the device, the user will be prompted to install it inside the support map fragment. So one of the really nice things about using support map fragment is that it takes care of all the complexity of showing a dialog and an error message to the user if they're on an older version of Play services or if they don't have Play services installed at all. This method, the onMapReady method, will only be triggered once the user has installed Google Play services and returned to the app. Here you can see that we're capturing the value of the Google map, which is the parameter here, saving it as a member variable in our class, and then we're adding a marker. So here's a marker for the latitude and longitude of Sydney, Australia, and we're adding it to the map, and then we're moving the camera, which means moving the view of the map to be centered on Sydney. That's why we're able to see this view here. So in order to show the data of the user map, which is the data from the map that was clicked on, we need to actually have access to the user map data inside of this activity. The way we can do that is if we go back to code path, we want to path data to the launch activity. And so what we want to do is we want to add extra data into the intent in the way that's being shown here. So we'll go into main activity, and as part of the intent, we want to put some extra data. And so typically the way this works is the first parameter will be a string, and the second parameter will be the value that you pass in. There's a key value, essentially. The key is always a string, and we'll call this extra user map. And then I'll define that up here. And the reason I'm not making this private is because we actually want to access user map inside of display map activity in order to get the value out. And the value of extra user map will be the user map data that was clicked on. So we'll say user maps at that position. You'll notice here that Android Studio is complaining. It says that there's no such method which takes in a string followed by a user map, because the user map is something that we've custom defined. The only things that are allowed as the value of a intent data are primitive types such as float, int, short, string, boolean, things like that. Or there's also something else called serializable. The idea of serializable, this is a concept coming from Java, is that you can take an arbitrarily complex data structure. So user map is one example of a data structure because it has different data inside of it, and you can serialize it, which means you can deconstruct it into bytes that you can send back and forth. And then you can later on deserialize it. So you can take those same bytes that represent the user map and actually reconstruct a user map object. And so in order to be able to pass the user map, we need to make the user map data class serializable. So let's open up user map, and it's as simple as extending the serializable interface. And this interface is empty, so actually there's nothing really to do except for extend it. And because we're making user map serializable and the place class is part of user map, we also need to make the place class serializable as well. So now going back to main activity, you can see that the error went away. And in display map activity, we can now retrieve the value of this user map. So I'm going to save the user map as a member variable. I'll say privately init var user map. I'll call it, this is a user map. And we want to get the value of user map from the intent. So we'll say intent.getExtras, get serializable extra, and we pass in the key, which is extra user map, and we want to cast this as a user map. So now that we have user map, let's actually just log something from it inside of onMapReady. Log.i. So just as a proof that this is working, we will just print out the title of the user map inside of the onMapReady callback. And let's define this tag. Okay, let's run it. And now there should be no behavior change other than we should have this log statement being printed out. So I tap on the first element. I again see the map view, the map activity, which is centered on Sydney, Australia. And if I open up logcat, we should see a log statement from display map activity, and we do. So we have memories from university. So this is proof that we are successfully passing data from this activity into the display map activity. The goal now that we have the user map data in this activity is we would like to be able to add a marker for each place in our map. The way that might work is we say for each place in user map.places, we'd like to do something similar to how we're adding a marker for Sydney. So first we'll define a latitude and longitude, which is based on the position in the map. So I'll say place.latitude and place.longitude. And then we need to add a marker by using marker option. So we pass in the position, which is latitude, longitude. Then we pass in the title. The title will be the title of the place object. And there's also one more field called the snippet, which will be the description of the place. Let's try it. So if I go to January vacation planning, which has locations from all over, you can see that we still have the marker from Sydney. And then we also have the markers which are legitimately part of the map. That looks good. So if we get rid of Sydney now, let's try this one more time. So you can see that we do still see the markers and we got rid of the Sydney marker. However, the map started out by looking at the very center of the equator and it's 0, 0 latitude, longitude. Instead, we'd like for the map to be centered and tightly focused on just the area which contains the markers. And there's a nice way to do this, which is using something called latitude longitude bounds builder. So we're going to say lat long bounds.builder. This is going to be a bounds builder. And the idea is that we want to keep adding latitude, longitude positions into this bounds builder. Include long. And now we can do something similar to what we already have with moving the camera map. Instead of saying new lat long bounds focused on a single latitude, longitude, we want to include the whole bounds. And this is going to be boundsbuilder.build. And there are two versions of this method. One is takes an additional int, which will describe the padding that you want on each of these. And the other version takes in 3 integers, which is the one that we're going to use. I'm going to pass in 1,000, 1,000, and 0. The idea here is that the markers of your map will take up a certain amount of space. If you want to constrain that to be a very small part of the view, you can add in the bounds of that here. By putting in 1,000, 1,000, that's large enough to make it irrelevant. So basically we're saying zoom in as much as possible. We don't want to constrain the amount of space for the bounds in our map. And then 0 means that we don't want any padding. Let's try it now. Okay, you can see immediately that the map zoomed into just the area which contains the markers. And if you go into something a bit more precise, like just Singapore, you can see that we are only seeing the Singapore area here. Awesome. One more thing, just in case you're interested in trying it out, there's a lot of nifty methods on the map object that we have here. For example, instead of move camera, I can say animate camera. And this does a really nice animation from the beginning until zooming in until you reach the destination, which contains all the markers. That's something you could try out. I'll go back to the move camera method just because the animation might get a bit tiring if we repeat it too often. One last thing we'll do is update the title of the new activity, the title of the action bar, to be the title of the map. And so as soon as we get the map object, then we can say get the action bar and set the title to be the user map.title. So if we run this now, we tap on one of the entries in the recycler view, we can see that the top of the activity is now updated appropriately to indicate what we're looking at. So we're able now to view a map that we already have, but we'd like to be able to allow the user to create a new map. So that's the goal for the next video. So if you're enjoying this, please like and subscribe, and I'll see you in the next video. The goal for this video is to implement the first half of the creation flow, which is the way for the user to create a new map. We want to add a click listener when the user taps on the floating action button, and when they tap on that, we go into this view where they can drop markers or pins onto the map and save it. The first thing we'll do is add a floating action button in the bottom right of our main activity. So the floating action button, or FAB, is the common Android way to indicate to the user that there is a primary action for the user to take, for example, create a new object. So the way we'll do that is go into activity main and then just search for floating action button and then drag that out. And you'll be prompted to specify the icon which should be inside of your floating action button. I'm going to indicate I want icy input add, which is just a standard plus button. Floating action button also requires a library, so Android Studio will include that into your build.gradle file for you. And we're going to constrain this view to the bottom and to the left. So I'll make it 32 dp, or 32 density independent pixels from the bottom and right. And then sometimes floating action button, I also have this weird bug in Android Studio where it doesn't actually render for me in the preview until I actually run the app. So let me see if that works. Yeah, now you can see that it does show up. Instead of the plus icon being a green color, I'd like it to be white. And there's an easy way to fix that. There's a tint, and you can just specify the color to be white. And there you can see it updated. The other thing we'll do is change the ID. I'll just make it fab create map. This is how we'll refer to it in main activity. So if we run the app, we'll just make sure that we're able to see the action button properly. Yeah, we are. Okay, and it is clickable. So what we want to do is we want to listen for clicks on that button in the main activity. So we'll say fab and then on click listener. And then first I just put a log statement. So what we want to do at this point is we would like when the user taps on the floating action button to navigate to a new activity, which is designed for the user to drop pins into the map and save it. When that action is done, when the user has finished their map and they want to save it, we would like for that new activity that we'll create to pass data back to main activity, the parent activity. And so this is a pretty common paradigm in Android apps. And so if you go back to the code path guide, below where we just were, which is a section about passing data to launched activities, there's a section about returning data result to parent activity, which is exactly what we're trying to do here. We're going to be calling a different method, start activity for result. And that what that's indicating to the Android system is that we're starting this activity, but we would like to potentially get data back from the activity that we're starting. And that requires passing in a request code. And a request code is arbitrary integer, which can be used to uniquely identify the request to that activity. So let's add that logic. So we'll say val intent is equal to intent, and then we're going to pass in the where we're coming from, which is this. And next we want to indicate the class that we're navigating to. So for that, let's open up the project pane and let's create a brand new activity, which we'll call create map activity. And again, this is going to be a map activity. So the nice thing is this is going to be a bit faster because we can utilize the same API key that we already used from last time. So there's only one file, Google Maps API, so there's no need to change that anymore. And then if we open up create map activity, it has the same exact starter code as what we had seen for display map activity. So for now, let's just navigate to this and we'll see the same thing, which is a marker on the Sydney location. And let's say start activity for result. And then we'll pass in intent along with a request code. And we need to define what this request code is. And again, like I said, this can be any arbitrary integer. So I'm going to say 1, 2, 3, 4. And so let's not worry, at least right now, about what will happen in create map activity. But when create map activity is done doing its job, which is to generate a new user map, we want to capture the result of that back in main activity so we can update the recycler view. So the way we can do that is by overriding a method on the activity class called onActivityResult. And this, you can see that it takes in a request code, a result code, and the data, which should contain the user map. So we'll first check if the request code matches up with our request code. And also we want to make sure that the result code is equal to result OK, which is the Android way of indicating that everything went fine. And if so, there should now be map information from the data object that we get passed back. Okay, one more thing we'll do before we run the app is before the user navigates to the new create map activity class, we'd like to prompt them to ask for the title of the new user map. For now, let's not worry about that. Instead, I'll just hard code in the value. But the way we'll communicate the title of that map into the create map activity is similar to what we're doing with the display map activity. So we're going to put extra and we're going to pass in a string. So we'll say intent.putExtra, and then I'm going to define another constant called title, map title. And then let's just hard code in some value here. And on the other end, on the create map activity, we'd like to set the title of the support action bar to be the map title that we passed in. Now we can try this. So I tap on the floating action button, and now you can see the hard-coded value, new map name, as the title of our activity. The way we'd like for the create map activity to work is the user can long press on any part of the map, and that will drop a marker at that location where the user can specify the title and description for that marker, for that pin. So the way this works is we can add a long click listener on the map, and then that will give us the location of where the user did the long press. So let's add a log statement so we can better keep track of this. Okay, and then whenever the user has made a long press, let's just put an arbitrary marker in with some hard-coded title and description information. So the position will be the position that the callback here gives to us. So the parameter could be that long, so that'll be the position. And then the title can be my new marker, along with the snippet, which is a description of a cool snippet. Let's try it. So now wherever we do a long press on the map, we should see a marker show up there. And if I tap on that marker, I see the title and description that we had hard-coded, and I can repeat this process as much as I want. One of the things we'll want is a data structure which will keep track of all the markers that the user is adding to the map, and so that when we save the whole map, we should be able to iterate through that and generate a user map from all of these markers. And so in order to maintain this, I'm going to have a variable here called markers. And this is going to be a list of marker. Actually, it's going to be a mutable list because we might be adding to it as the user does long presses. And initially it'll be empty. So every time the user adds a marker with the long press, we want to add that to our list of markers, this member variable. The way we can get a handle on the marker is by capturing the return value of mmap.addMarker. So I'll say now markers.addMarker. One more thing we'd like is to allow the user to delete markers that they've already put onto the map. And I'm sure there's a better way to do this, but one simple way I found to make this possible is if the user taps on the info window, which shows up when you tap on a marker, that can be an indication that they want to delete that marker. So I'll say mmap.window click listener, and then here we want to delete the marker. On window click listener, delete this marker. And this is convenient because the parameter for this function is the marker that we want to delete. And so in order to delete this, the first thing we'll want is to delete it from our list of markers. So we'll say remove, and we want to remove that guy. And then we also want to remove this marker from the map. And the way that works is you say marker to delete dot remove. Let's try it. It looks like we have an error here. Yeah. So I think we need to specify a mutable list of marker. And then actually we don't need the type parameterization anymore because that should be inferred from the declaration. Okay, so what we expect now is we should be able to long press and that will drop a pin like before. But now if I tap on the window, it should delete that marker. And you can see it does that properly. Now we'd like for the user to be able to customize the title and snippet when they're adding a marker onto the map. So instead of immediately adding a marker with the hard-coded values, instead let's show an alert dialog where the user can input the information they care about. So I'm going to have a method here called show alert dialog, and we're going to pass in the latitude and longitude here because we'll need that when eventually we add the marker. And so all of this stuff we're going to move down into the show alert dialog. But we only want to do this if the user has tapped OK on the alert dialog and they have the information filled out. So to learn how to show an alert dialog, open up this guide from CodePath called Using Dialog Fragment. And then if you scroll down a bit, there's a section here about building a dialog by customizing the available dialog object. So that's what we're going to start out with. We'll get a new alert dialog builder and we'll set various attributes on that. This takes in a context. And we will set various options such as title. Just for now, we'll say set message as hello, and we'll change that later. And then we'll set a positive and negative button. And when you call .show, this is actually going to now return to us a dialog. Let me clean this up a bit. And then what we'd like is we only want to add the marker onto the map if the user has tapped on the OK button, the positive button. The way we can set that up is we'll grab the button, the OK positive button, and then we're going to set a click listener on this. And so only when it's clicked do we take this action. Let's try it. So now if we do a long press, we should see an alert dialog and it shows create a marker along with the message, which is hello, and we have the two buttons as we expect. If I tap on cancel, we don't see a marker, but if I do tap on OK, we should see a marker show up. One thing that I forgot to do is if I tap on OK, we should now dismiss the dialog. Okay, so the next step is instead of just having the hello as the message of the alert dialog, we actually want a custom view, and that custom view will contain two edit texts. These two edit texts will be one for the title and one for the description. The way we can do that is by calling this method setView instead of setMessage. And this is now going to be the view which contains all the information. Place form view, and then we're going to create this view up here. So I'm calling this layout dialog create place, and now Android Studio will help us to create a layout resource file with that name. And linear layout is a good root element because it's going to be very simple, just 2 edit text stacked on top of each other. So linear layout by default will be vertical, which is what we want. And then let's add in 2 edit texts here. So the name, and then right below that is one more edit text, which will be for the description. So the first one, which currently says name, we would like it to say, the hint should be title. And then the one below that, the hint should be description. And the ID of this one should be ET description. And then this should be ET title. And then one more thing we can do is set some padding on the linear layout, at least on the beginning and end, so that it fits more nicely with the alert dialog, because everything else in the alert dialog will have some padding. I'm going to search for the padding attribute, and then let's just add 15 dp at the start and at the end. Another thing is, because the title is more important or more prominent, let's make the font of that one bigger. I will make it 24 SP. Okay, so we've defined the dialog create place properly, that this works, and now place form view, it should show up when we are long pressing on the map. Yes, it shows up properly. One thing that looks like a mistake is I changed the hint text of the second edit text, so I didn't get rid of the default text, which is name. So let's go back and clean that up really fast. So the hint should be description, and that looks much better. So now, when we have tapped on the OK button, we still don't want to add a marker until we've done some sanity checking on the form. So if the user hasn't inputted any title or any description on that marker, we don't want to allow them to create a marker or a place in the map at that position. So in general, whenever you're dealing with user input data, you need to be very careful about sanitizing and making sure that data is validated. So we're basically doing error validation and form handling right here. So what we want to do is check the value of the different attributes in the place form view. So the title will be place form view dot find view by ID, and it's going to be an edit text. And the ID is ID dot title, ET title, and we'll get the text and call toString on it, and this will give us back the string version of the title. And we're going to do something quite similar for the description, except the ID is ET description. So the idea is that if either the title or description is empty, then we should not allow the user to create a marker there. So first thing I'm doing is trimming it so that in case the user puts in a space bar, there's empty space. We still don't want to allow that. So then we can, at this point, say toast place must have non-empty title and description. And then if this happens, we want to return from this on-click listener on the positive button. And then let's make the toast show up for a long amount of time. Okay, and if that worked, so we have a valid title and description, we want to update the marker to include these values. Let's try it. So I tap on the floating action button, I drop a marker here, and I'll say Western Australia. If I tap on OK now, I properly see this error message, and if I tap in a description, now I should be able to submit this marker. And then the window, as expected, does show the values I inputted. If I tap on it, I'm able to still delete the marker like we did previously. Okay, the last thing I want to do in this video is give the user some education about how they can create a map, because it's not that intuitive that you need to long press in order to be able to create a marker. And so to do that education, we're going to be using something called a snack bar. So snack bar, if you open up the code path guide, is a component which is shown at the bottom of the screen, and it contains text with the optional single action. So these are pretty common as an elegant way to inform the user that something has happened, or if you want to provide some information to the user. So the way this works is you say snackbar.make, you pass in the parent view, and you provide the text and a length. So let's do that at the very beginning, as soon as the view is created. So we'll say snackbar.make, and then we'll pass in the view, and the view will be coming from the map fragment. And then here's the message, long press to add a marker. And the length of our snack bar will be infinite, length indefinite, until the user taps on the action option. And so for us, we are going to have an action which just says OK. And we won't do anything special when you tap on OK. We'll just dismiss the snack bar, which is already happening by default. The color of the action should be white, because by default the snack bar will be black, so we want it to be maximum contrast. So we'll say, we'll pass in white, and the way we do that is you need to pass in context compat, get color, pass in a context, and then actually pass in the color. So android.r.color.white. And finally, we should need to call show in order for the snack bar to actually show up. You'll notice here that Android Studio is complaining that mapFragment.view might be null, and so it's recommending that we use this syntax, which is saying that we only execute this code if the view of the map fragment is non-null. This is an elegant way of avoiding a null check. So if we run this now, we expect as soon as we tap on the floating action button that we see a snack bar at the bottom of the screen. And you can see that we see long press to add a marker. If I tap on OK, it goes away, and then we have the same functionality as before. So at this point, the hardest part of the creation flow is done. The next video will wrap up with the creation flow, and at that point we'll be almost done with the whole app. So if you're enjoying this, don't forget to like and subscribe. Let me know if you have any questions. See you in the next video. The goal in this video is to finish what we started in the last video, which is the creation flow. The next step is we'd like to be able to add a save icon in the top right as part of the action bar. And when you tap that, that is what will trigger collecting all the data for this map, this user map data class, and passing it back to the parent activity, which is the main activity. So first, let's start with adding an icon into the action bar. The way we'll do that is through an Android system called menus. The first thing we'll want to do is add a new resource directory which will contain all of our menus. And now we want to create a new menu resource file called menu create map. And we'll fill that in shortly. But first, let's reference that new menu file that we created. The way we'll do that is start typing on create options menu. And here we need to get the menu inflator, and then call inflate, pass in the menu resource file that we just defined, and pass in the menu, which is a parameter to onCreate options menu. We're going to define various actions in the menu. When one of those is tapped, we want to get notified in the create map activity. The way that works is by overriding a method on options item selected. And here we want to check if the item selected is the save icon. Okay, let's go back into menu create map and fill this out. So here you can see that the palette of the options of what we can drop onto the menu is much smaller, which makes sense because menus are purposefully constrained. And the thing that we're going to be dragging out is a menu item. And so by default, this will create a menu item which lives inside of these three dots, which is called the overflow menu. So by default, everything will live inside the overflow menu. Let's give this menu option a different name. We'll call it save, and I'll give it an ID of mi save. That stands for menu item save. We don't want the menu option to live inside of these three dots where you either have to tap on it and then tap on save. Instead, we prefer for the action to always be a first-class citizen in the action bar. And that's what show as action represents. If I expand this, you can see there's a couple different options here. Always means always show this menu item as an action, which means it should not go in the overflow menu and will always be displayed in the action bar. Never means it will always be in the overflow menu. If room means if there's enough screen real estate, only then do we want to show it as an action and promote it into a top level. Otherwise, it'll live inside the overflow menu. We want always because we always want the save option to exist. So once I say apply, then you can see that instead of the overflow menu now, because there are no other menu options, the save text shows up as part of the action bar. Instead of it being text, we'd like it to be an actual icon. So I'm going to select an icon here. I'll just search for save, tap OK, and now it shows up as an icon. So let's go back into create map activity. Now we can compare the ID of the menu item selected with the ID of the option we just defined. So if these are equal, then we have tapped on save, and in this case, we'd like to return true because we want to stop further propagation of menu options items selected. So what we'd like to do here is create a map based on the marker data that we have, and then pass that back to the parent activity. Before we do that, again, we need to do error handling. So if the markers that we've saved so far is empty, that means the user hasn't dropped any markers onto the map, then we don't want to allow them to save the map. So we'll say if markers is empty, then we want to show a toast and say there must be at least one marker. And then we want to return early in that case. Otherwise, what we'd like is to generate a user map. And this takes in two things. First, it takes in a title. And the title, we can get it pretty easily from the intent. And the second parameter is a list of places. So to generate a list of places, we're going to iterate through the list of markers. And for each marker, we're going to generate a place. There's a really nice way to do this using something called the map function. And what that does is it'll iterate through a list, and it'll operate on each element of that list and transform it in the way you specify. So we say markers.map, and then on each marker, we're going to do a certain action. In our case, we want to generate a place for each marker. So the place takes in a title, description, latitude, and longitude. And these all will come directly from the marker. So we'll say marker.title, and then the description will be the snippet of the marker. And then the latitude and longitude will also be coming from the marker.position and then latitude, longitude. So the result of mapping this is we're going to transform the list of markers now to a list of places. And that will be the second parameter of our user map. So we'll say val user map. And now that we've defined this user map, we need to pass it back to the parent activity. The way that works is we'll say val data is equal to new intent, and we'll pass the user map as extra data onto this intent. I'm going to utilize the extra string that we've defined from main activity, which is extra user map, and then pass in the user map here. And finally, we'll say set result with activity result OK, and pass in the data here. And then call finish. So when we say finish, what we're telling Android to finish this activity, which means the create map activity, and go back to the parent activity. And we're going back to the parent activity with result OK and with the data which contains user map in it. So once this happens, we should then come back into on activity result, and let's see if we're able to actually get into here. So we'll put a log statement, and I'll say on activity result with new map. And we need to get the user map out of the data. So I'll say user map is equal to data, get serializable extra, and extra user map. So here we are looking at the data and getting serializable data out of it using this string, which we defined already. And this is of type serializable. The Android system doesn't know anything beyond that. It's just kind of a binary blob. And we're casting it here as a user map. And this is what we're actually going to be able to modify and deal with. So we'll say user map dot title. Okay, let's try it. So I'm going to create a new map by tapping on the floating action button. I'll say hello, hello, and save. Let's see if we got anything inside of main activity. Okay, yes, we do see on activity result with new map title, new map name. And new map name is actually the hard-coded value that we've passed in up here, which we're going to change later. But this is proof that when we tap on the save icon, we are able to successfully get into here. And because the markers is non-empty, we're able to keep proceeding. We generate a user map, and then we call finish, which then goes into on activity result from main activity. So once we get the data back in main activity, we want to modify the data that's used to render the recycler view. So in order to do that, we need to be able to reference the user maps and the adapter. So I'm going to do some surgery on this, and I'll say private late init var user maps. And there's going to be a list of user map. And then similarly for the map adapter, it needs to be its own variable here. Map adapter. Okay, so now user maps and map adapter are member variables of the class, and we can reference them in any method. So first thing we'll do is add the user map that we have to the list of user maps. In order to do that, we need to make user maps a mutable list. And that means that here we actually generate sample data currently is returning back an immutable list of user map. So first we need to cast it, or we need to change it into a mutable list, to mutable list. And now we should be able to call .add on this. So we'll say user map. And finally, we need to notify the adapter that something has changed in the data. We'll say map adapter .notify item inserted. And the position will be user maps.size -1. The last position is what we just inserted. So let's try this. If we run it, we'll do the same experiment as what we did before, but now when we come back, we should see another entry at the bottom, and the title of it will be what we've already hard-coded, which is new map name. Let's see. I'll just add one arbitrary marker. And there you can see that we do see new map name. If I tap on that, we only had one marker on that map, but you can see that it does show up successfully here. So let's do some quick updates. So first, when you go into the create flow, you'll see we are showing this dummy marker. Let's get rid of that. I'm going to clean up the comments a little bit as well. So we don't want to show a marker at the initial location. And right now it's starting out at Sydney, but just to make it more relevant to where I am, let's start this out in Silicon Valley. So the coordinates of Silicon Valley are 37.4 and -122.2, so we can put that in. If we try that, let's see how it looks initially. So there you can see it does center in Silicon Valley, but it's super zoomed out. I'd much rather it be zoomed in quite a bit closer so you can at least make out where we're looking. And in order to do that, there's another method on the camera update factory called new lat long zoom. And the second parameter here is you provide a float which indicates a zoom level. So I'm going to specify a zoom level of 10. So the zoom level is a number between 1 and 21, where 1 is zoomed out as much as possible, like the whole world, and 21 is down at the street level, so as detailed as you can get. So 10 is right in the middle, is looking at city level, which is appropriate for if you're zooming into Silicon Valley. Let's try it. Great, and that looks pretty good. So now you can see that we're able to see a bunch of the cities, San Jose, Palo Alto, SF, which is the heart of Silicon Valley. One more thing we should do is right now, when we create a map, we're always seeing new map name as hard-coded. Instead, we'd like to be able to allow the user to specify the title of their new map instead of having a hard-coded value here. In order to do that, we're going to do something very similar to what we've already done with create map activity, which is we're going to show an alert dialog. So I'm going to copy this method and put this in main activity. And we're going to have to tweak it a bit. So the title of the alert dialog that we'll show is going to be called map title. And we're going to have to define a new dialog for this. I'll call it dialog create map. And then have Android Studio help us to create this. And it'll be a linear layout, that's fine. And this will be a simple edit text. It'll be a single view. So I'm going to have the hint be title. And the ID can be ID title. Let's make it similar to the other one. It will be 24 SP, so it's a little bit larger to indicate that it's title. And let's also, on the linear layout, the parent, let's change the padding as well on the start and end, 15 dp. Okay, going back to main activity, so now we've defined this custom layout. I'll call this map form view, just because it's a form which is about creating a new map. And here, we're going to have a title like we have before, and the ID is the same, but there's no more description, so we can get rid of this as part of the error handling. So then we can say map must have a non-empty title. Okay, so we only want to navigate to the create map activity if we've gotten here. Because at this point, we validated that the user has inputted a proper title. So here we can do the navigation. And then instead of the hard-coded value of new map name, we want to pass in the title. And now all that's left is we need to call show alert dialog. And then this doesn't need any latitude, longitude, so we'll just call it with no parameters. Let's try it. So now instead of navigating directly to the create map activity, we should first see a dialog, and it asks us for the title, so I'll call it my new map. And you can see that the title of the action bar does update properly to show my new map, and if I indicate something like Redwood City is here, and then maybe one more for good measure, I'll say San Jose is here, and save it. So now we have this new map show up with the name that I inputted, my new map, and if I tap on it, it does properly show the two markers that I had added. So this is pretty great. We're able to show interesting data to the user by tapping on one of these maps, and the user is actually able to create data by tapping on the floating action button. However, one of the frustrating parts of the app is that there's no way to currently persist the data, right? So if I close the app and I open it again, you can see that that new map I had created which had Redwood City and San Jose, is no longer there. So a user may spend a bunch of time creating a new map and expect it to be there when they come back in a day or two to the app, but now it's gone. And so the next video, we're going to implement the persistence part of our application. If you enjoyed this, don't forget to like and subscribe. Let me know if you have questions, and I'll see you in the next video. In the last video, we finished up the creation flow in our My Maps application. However, there was an issue in that whatever data the user creates, whatever new map that the user creates, is transient, in the sense that if the app gets killed, then whatever data the user has added into the app will get destroyed, and there's no way to retrieve it. So our goal for this video is to add persistence into the app by writing the data, the map data, into a file. So for some background on this, if you go to Google and just search for persisting data CodePath, CodePath has a really nice guide which documents the different approaches to persistence in Android. So first we have shared preferences. Shared preferences is a way to easily save data as key value pairs. So for example, if you have the option in your app to customize the background color to make it red or black or white, then that might be a good candidate for shared preferences. Local files is what we're doing, and so we're going to be saving arbitrary files to internal external device storage. And the last two are dealing with databases. So SQLite is the standard database in every Android app, and that's how you can actually save structured data. And then ORM refers to object relational mapping. So it's a wrapper around your SQLite database, which allows you to do higher level queries on your data. So here you can see some of the use cases. The shared preferences, like we talked about, are used for app preferences like setting background color, keys, or session information. Local files are often used for blob data or data file caches such as disk image cache. And the last two, SQLite database and ORM, are used for relational data. And so in reality, given the kind of data that we have, which is a user map, and a user map contains a list of places, our data is inherently relational. So really, we should probably be using SQLite database or ORM. And that actually provides other benefits because we can query for some part of the data. It's kind of a hack that we're actually using a local file to store all the user maps, but that is going to be much simpler for us. The idea is that we're going to take all the data, all the user maps that we have, write it to a file whenever a change happens, and when we open up the app for the first time, we'll read from that file to show the user a list of all the maps that have been created. So there are obvious disadvantages to this approach. For example, if you have hundreds or thousands or even millions of maps, you can very quickly see that there's no way you can store all that data onto a single file. It would just be too slow. You would want to be able to query and say, I want the last 100 or last 20 maps and only show those. And in the approach that we have, there's no easy way to do that. However, for our purposes, writing to a local file will suit our needs just fine. And we're really going to embrace this idea of done is better than perfect. So if we scroll down to the section about local files, you can read a little bit more about how we're going to be dealing with reading and writing to a file. But the main takeaway is that every app on Android will have a dedicated directory where it can read and write files. And so if we go into main activity, we're going to add some methods at the bottom here. The first, I'm going to add one which is called private function get data file. And the responsibility of this method is to return the file which other methods can read from and write to. And so first we'll have a log statement here. And this is going to print out the directory where this file lives. And the way that works is we are going to get the context. So we actually need to pass in the context object here. And then get the files directory. So files directory is an attribute on the context, which is the absolute path to a directory on the file system where files created with open file output are stored. So that's what we want. And then we want to return a file with that directory. And then the second parameter of file is a string, which is the file name. And so we're going to define a file name at the very top. So we'll say private const val file name, and this is going to be a file called usermaps.data. And this can be kind of whatever file name you want. Okay, so now there's going to be two more methods. One which will be for reading the user map data from the file, and the other which is given the user map data, we want to write it into the usermaps.data file. So the first one, which is reading from the file, that is the process of deserialization, and writing to a file is called serialization. User maps. And this will take in two parameters, one which is the context, because we'll need to be calling the getDataFile method, and second is the user maps that we want to write out. And so we'll say user maps. This is going to be a list of user maps. Okay, and so here we want an object output stream, and this takes in a file output stream. The idea here is that we want to get the file output stream and pass that to an object output stream. So that means we can take an arbitrary object and write it to the file. And the thing that we're writing is user maps. And the reason this is possible is because user maps is serializable. We implement that serializable interface. So basically you can think of this as taking a data structure or an object and then breaking it down into its component primitive parts. This is going to write out some binary data, some byte data. There's one more method, which will be private fun deserialize user maps. And this takes in one parameter, which is the context, but it'll actually have a return value, which is a list of user map. So here, let's also do another log statement, just so we know when it's getting called. And then we'll call getDataFile with the context. Let's capture the return value into data file. So if the data file doesn't exist, that's the first thing we should check, right? If the very first time you open up the app and we try to read from the file won't even exist. So in that case, just return. We don't want to return any data. So let's just have a log statement for that. Otherwise, the data file does exist, so we want to read all the information from the file and create a list of user maps from it. And the way we'll do that is essentially the opposite of what we have in line 95. The object input stream and then file input stream. And here we want to pass in, or we want to call the read object method on the input stream. And then we'll cast it as a list of user map. So the only thing left now is call these methods at the appropriate time. So deserialize user maps should be called whenever we want to display the list. This happens at the very beginning when the app is being booted up. So I'll call deserialize user maps, and this will return to us a bunch of user maps. And we'll add these all into the list of user maps that we already have. And then we need to pass in the context for deserialize user maps. The other method, serialize user maps, should be called anytime any of the data around the maps changes. So in our application, the only time that happens is when the user creates a new user map. So in particular, that happens right here. In onActivity result, we get back a user map, and we are notifying that a new user map has been inserted. So right here, we would like to call the method serialize user maps with the context and the updated list of user maps, which has the newly created one. Let's try it. And I'll open up logcat and let's look at main activity logs. So when we start the app, the very first thing we try doing is deserialize user maps, and that will look in this directory, data/user/0/package name/file. So that's where all the files will live. Of course, right now, the data file never has existed, so we get that log statement. If we now try to create a new map, I'll give this a title of California. I'll call this Silicon Valley, home of tech giants. And then I'll put one more in Santa Cruz. Well, let's save it. Okay, so we do get the new map for California created, and let's take a look at the logcat output. So we have on activity result. This is from before. So we have a new map with title California. Then we're calling serialize user maps, and so here is where, if everything worked properly, we should have outputted the entire set of these maps into that file. So one way to test this is if I kill the app now and I open it up again, that new map called California should still survive. And you can see it does show up, and the reason we're seeing duplicates of these other maps is because when we first create the activity, we're getting the sample data, and then on top of that, we're adding the previously saved maps. So now we don't need the sample data anymore. So let's get rid of that. And actually, we can just combine these into one statement. So here, we're not looking at the sample data at all anymore because we've saved all the sample data into a file. And here, we're just deserializing all the contents in that file into a mutable list, and we're making that the member variable user map, which is how we're displaying the recycler view. So if we try it one more time, now we should see just the 5 original maps plus the map I just created called California. Adding persistence into the app makes it way more usable because now all the time I spend to create my own maps can actually survive and I can reference them later on. In the next video, now that we're done with all the core functionality, we're going to add some polish onto the app and also do a high-level review of everything we've covered. Don't forget to like and subscribe. Let me know if you have any questions. See you in the next video. If you've gotten this far, you've built out a really full-featured Android app. We allow the user to view the maps that they've created and also allow them to create new ones. And we're saving these to a file so that we have persistence. The goal for this video is to polish the app and also do some concept review. In terms of polish, I had 2 ideas of simple things we can do which will improve the design and the look and feel of the app. First, you'll notice that if I tap on the floating action button, you can see that there's some sort of ripple animation where the background of the button becomes a little darker. And this gives the user a really nice feedback mechanism that they've tapped on it. I'd like the same thing to happen when I tap on one of the recycler view elements. Right now, I don't get any kind of feedback. The way we can make this work is by opening up Maps Adapter. And right now, each view in the recycler view is an inbuilt simple list item 1, which is coming from the Android SDK. All this is a text view. Instead, we can create our own layout and we can apply some styling on that to have this background effect. So first, let's go into the layout, into resources, layout, and define a new layout resource file. I'll call it item user map, and the root element can just be a text view. Okay, so some of the tweaks we can do here is The ID, let's give it an ID of TV map title. Width of match parent is fine, but the height should be wrap content. It should just be tall enough to fit the contents. Let's give it some sample text. We'll say Singapore. And then let's make the font a little bigger. And also let's add some padding. I'll put 10 dp of padding all the way around. So if I apply it on this, that means it's saying apply 10 dp on all four sides. And finally, in order to have that selectable background for that ripple animation, the way we do that is by specifying a background. To get a bit more context, Google for CodePath ripple animation, and you can check out this CodePath guide. Ripple touch effect was introduced with Android 5.0, API level 21, which is a few years ago now. Most phones should be running 5.0 or higher, and that's what gives us this nice effect of giving the user feedback of wherever they tapped on a button. The way we can make this happen is by having a selectable item background as the background attribute. So if I go into here and I search for background, and then I search here, and then just search for selectable item background, and it should show up. So now, if we reference this newly created text view layout in the adapter, we should see the animation. So I'll say item user map, and we need to make sure that we update the reference here because the ID has changed. So we called it ID TV user map, TV map title. Let's try it. And we also expect the text to be larger now. Okay, so it does look bigger, which is good. And if I tap on one of these, you can see that we do see the background become darker, which feels a lot nicer to the user. I get a lot more intuitive sense of what's happening. The other improvement I like to make is an animation. Right now, when I tap on the recycler view and I go into the detail view, there's not really a clear activity animation from one screen to the next screen. But Android has really nice support for this. So if you go to the CodePath guide about animations, there's a section here about activity transitions. So all you need to do in order to create these screen animations is call this method override pending transition after you call start activity. So let's try that. So into main activity, wherever we call start activity, which is here, I'm going to call override pending transition, and this takes in two parameters: the enter animation, so the new activity which we're navigating to, how does that enter, and the current activity which is being exited, how should it exit. And so Android has a few built in, so let's try those initially. So for the enter animation, I'm going to just try out the slide in left. And then for the exit animation, I'm going to try out the slide out right. Let's try it. So now we expect something unique to happen, something different to happen when I tap on this in order to get to the detail view. So you can see how the main activity kind of moved out to the right, and then it feels like the map activity took its place by sliding in, which is pretty cool. However, at least for me, what's intuitive is the master view, which contains the index, or a list of all the views, should slide out to the left, and the entering view should come in on the right side. So I actually would prefer that these are flipped. So in order to do that, I'm going to copy this and just tweak it to fit that requirement. So I'm going to copy this. So we're going to create a new resource directory, and this is going to be of type animation. So we're going to create two animation files which are going to mirror the built-in one, slide in left and slide out right, but they're going to be opposite. So we're going to have slide in right instead of slide in left. And let's put this in. And in order to make it slide in from the right instead of the left, we need to start the X delta at 50% and then move to the neutral position. So what this is saying is start from this position and end at this position. So instead of starting at -50, which means we're starting off the screen to the left and going into the center of the screen, we instead want to start off the screen to the right and then come in to the neutral position. And then we want something similar for slide out right. So let's copy this. Slide out left. And then similarly, we're going to start at the neutral position and we want to move left instead of right. So the only change I need to make is the 2x delta should be -50 instead of +50. So now that we've defined those, we can start referencing them here. So I'm going to get rid of the Android prefix and then I'll say slide out left and then slide in right. So let's try this one more time. So we should see an animation where there's the main activity, which has the recycler view, should move out to the left, and the map activity should come in following that, in some ways replacing it, coming in from the right. Nice. So you can see that it does that. And that, at least to me, it feels really natural that we've selected something in this view and then we're naturally sliding in to figure out, to learn more about what's inside of that map. Like usual, there are a ton of extensions that you could do now that you've built out the base implementation. First, the map creation should start at where you're currently located. So right now we're always hard coding this to be Silicon Valley, but it probably makes more sense to drop the user off where they're currently located because that's more likely where they're going to be creating maps. Another extension you could do is show more info about maps in that initial recycler view screen. So right now we only show the map title, but you could imagine how it could be really valuable to show the number of markers, for example. Or if you wanted to integrate users, you could have the username of whoever created that map in the recycler view. And then one more idea I had was store the data on a server. Right now, as we talked about, it's kind of a hack that we're storing things in a local file, and you could change it into using a SQLite database such as Room. But another extension you could do on top of that is actually putting the data in the cloud, in a server somewhere using Firebase or Parse or whatever you want to use. And that could unlock a lot of functionality with being able to share your map with other people. So those are just a few of the ideas I had. Let me know if you have any other ideas, and if you implement any of them, definitely drop a comment, and I'd love to check out what you make. So there's a lot that we've covered in these set of videos. First of all, we used a recycler view to render the list of map titles on the main activity. When you tap on the floating action button, we navigate to a new activity, and all the navigation is happening through the intent system on Android. And that brings you to this screen, and we're using a menu in order to show the save icon. Then, of course, we're using Google Maps API in order to render a map, and we're using different operations on the map object, such as on long press listener or on window click listener, in order to be able to drop pins and leave details about each marker. And finally, we're using input and output streams in order to take all the map data and persist it into a file. I hope you had fun building out this application. I'd love any feedback, whether you got stuck at a particular place or if you just built out a really cool map and you wanted to share. I'd love to see it. That's all I had for now. Don't forget to like this video, subscribe to my channel, and I will see you next time.